So hi all, my name is Arvind Chauhan. We are starting a new playlist for this algorithm. This algorithm series we will start in Hindi, and you can also check out the playlist that is already I have created in English. In this playlist, we'll cover all the entire algorithm concepts, so you can just go through. So this playlist will be helpful for all the engineering students or university students or who are preparing for GATE examination or NET examination. In this session हम डिस्कस करेंगे एल्गोरिदम कोर्स डिटेल्स. सो एजेंडा इस सेशन का है कोर्स आउटलाइन हम डिस्कस करेंगे एंड कौन सी रेफरेंस बुक है जो हम फॉलो करने वाले हैं. बेसिकली इस एंटायर प्लेलिस्ट में हम जितने भी एल्गोरिदम कॉन्सेप्ट हैं वो कवर करेंगे इंक्लूडिंग एल्गोरिदम इंट्रोडक्शन एंड कॉम्प्लेक्सिटी. सो इन दिस पार्ट we will discuss what is algorithm, how we can calculate the time complexity and space complexity, and what is time and space trade-off. Second topic हम discuss करेंगे that is algorithm designing approach. So you know we have so many designing approach for designing a particular algorithm. Later we will discuss. Third one is advanced algorithm and advanced topics. Under this topic, we will discuss advanced algorithm as randomized algorithm, approximation algorithm, and some advanced topics as NP completeness, fast Fourier transformation, and some algorithm that is belongs to pattern matching. And the last topic will be advanced tree. In this advanced tree, we will discuss binary search tree, red black tree, and B tree. As I told, in this topic, algorithm introduction and complexity, we will discuss algorithm introduction, steps to design an algorithm. What are the steps should be followed when we are designing an algorithm? What is the need of analysis? What is the need of analysis? Why analysis is required? So we'll discuss performance analysis, algorithm complexity, space complexity and time complexity, growth of functions, and asymptotic notation. We will discuss big O notation, big omega notation, uh, theta notation for that. So if you calculate the complexity, then how we can measure? So we will discuss in this part and the recurrence relation. So some algorithm in recursive nature. So we cannot directly calculate the time complexity for that. How we can calculate the complexity of such algorithm? So we will calculate complexity through recurrence relation. As you know, merge sort have some recursive functions. So you cannot directly calculate the complexity of merge sort. So we write a recurrence relation and then we have to solve that recurrence relation and then after we have to calculate the complexity. So as I told, these are the algorithm designing approach: divide and conquer, greedy approach, dynamic programming approach, branch and bound, and backtracking approach. So in divide and conquer, as a name describing, that is divide and conquer. First we have to divide a particular problem, then up to certain conditions, certain whenever you can directly solve that sub problem, then we have to combine the solutions in the bottom up approach. So that is divide and conquer approach. Greedy approach, we will discuss greedy approach in later, and we have and each and every designing approach have its applications. So in greedy approach, basically we have to find the optimal solution that particular moment. That is the greedy approach. As name suggests, that is the greedy one. Dynamic programming also have the optimal solution, but that have all the moment, not a particular moment. So branch and bound, backtracking, we will discuss later all the designing approach, including the applications. So as I told, each and every designing approach have its application. So वो हम discuss करेंगे. Binary search, merge sort, quick sort, and matrix multiplication. These are the application of divide and conquer approach. और मैट्रिक्स मल्टीप्लिकेशन में हम डिस्कस करेंगे स्टारसन्स मैट्रिक्स मल्टीप्लिकेशन दैट कम्स अंडर डिवाइड एंड कॉन्कर अप्रोच। वी विल डिस्कस वन बाय वन ईच एंड एवरी एप्लीकेशन एंड उसके बाद वी हैव टू फाइंड कॉम्प्लेक्सिटी। सो वो भी हम डिस्कस करेंगे कैसे हम कॉम्प्लेक्सिटी निकालते हैं पर्टिकुलर एल्गोरिदम का। सो फर्स्ट वी विल डिस्कस एल्गोरिदम, its basic and how we can identify. Suppose an example, binary search has complexity log n. So वो log n complexity कैसे आता है? That we will discuss. We will evaluate the algorithm. We will calculate the complexity of binary search. Second one is greedy approach. So these are the applications of greedy approach. Knapsack problem, job sequencing with deadline, minimum cost spanning tree, half-man coding, and single source or test path. So minimum cost spanning tree cover Prim's algorithm and Kruskal algorithms, and single sort shortest path algorithm covers the disaster algorithm. Each and every application we will discuss, including the complexity. This is the dynamic programming approach. ये dynamic programming approach का applications है. Knapsack problem, all pair shortest path, matrix chain multiplication, longest common subsequence, multi-stage graph, and traveling salesperson problem. And all pair shortest path में हम discuss करेंगे Floyd Warshall algorithm. These are the application of branch and bound, knapsack problem, assignment problem, and traveling salesperson problem. So यहाँ पे कुछ ऐसी applications हैं जो जिसको हम different approach से solve कर सकते हैं। जैसे आप देख पा रहे हैं knapsack problem and traveling salesperson problems। ये ऐसा problem है जिसको आप multiple approach से solve कर सकते हो। So you will find in dynamic programming, greedy approach, and branch and bound. These are the application of backtracking, knapsack problem, subset sum problem, NQ problem, graph coloring problem, and Hamiltonian circuit problem. So this is the portion of, or this is the section of advanced algorithm. As I told earlier, in advanced algorithm में हम discuss करेंगे approximation algorithm and randomized algorithm. Approximation and randomized algorithm. और साथ साथ भी हम discuss करेंगे application of approximation algorithm and randomized algorithm. And these are the advanced topics: NP completeness, string matching, and fast Fourier transformation. So ये string matching में कुछ algorithm है that is very important for the gate point of view and the university exam point of view. So we will discuss all string matching algorithms. So last one is advanced tree. So as I told, in advanced tree में हम discuss करेंगे first binary search tree, because this is the base for the red black tree, and then B tree, and after that we will discuss the heap, binomial heap, and Fibonacci heap. And these are the reference book we will follow in the entire playlist. So first one is very important book, that is the Introduction to Algorithm, this book, and this is written by Thomas H. Corman and printed by Prentice Hall. So this is very good book, so you have to follow this book all the time. Second reference book is the Fundamental of Computer Algorithms. So that is written by the Howard Sahani, and that is from the Galgotia publication. And third book I found, this is very good book, so you can also consider this. That is Algorithm Design and Analysis by Harsh Basin, and that is published by the Oxford University Press. So you can consider this book. And the first one is obviously is very good book. This is the base book for all the algorithm concept. So you can have a look for those books. Apart from this, I will provide each and every topic in details, including the notes. So आप उसको follow कर सकते हो. And you should always follow this book. इसको book को आपको पढ़ना चाहिए. It is very good. So thank you for watching this video. You can like, subscribe this channel, and you can also share those videos to your colleagues. And if you have any doubts, any concern, you can put your doubt and concern in the comment box. So accordingly, I can have a look and provide the solution to you accordingly. Thank you.